Why this must be finite? Because
You can open it.
you can figure out for yourself. Multiply triangle inequality. And then I need to do expectation of, this is the crucial part, how to prove the martingale property. Okay. Wt square minus t given
Yes.
fs. Okay. So this is what that I would like to show, that is going to be same as, ws
Minus
square
S.
minus s. Okay. This guy is constant, so I can put it outside. Not a big deal.
Okay.
The question is, what should I do with it? So the trick is this, always, and this trick always works. So you have two instants. So one is, so 0, S and T. Okay. So, and you have a process that is, for example, defined from 0 to T. So just break it into Ws, in other words, process that is defined here and in this, defined here, because I know that they are independent. Otherwise, do this. In this expression, I'm just modifying the same expression. Add Ws, Wt, subtract Ws and add Ws. Fn squared. This work. So this trick always works. You have to think in an example. So what would be this? This is going to be Wt, for example, if I treat this as a single entity, so it's going to be Wt minus Ws square given Fs. So what is the relationship between Wt minus Ws and Fs?
Measurable.
Not measurable.
Independent.
Independent. So it doesn't add anything. Okay? Doesn't add anything. You can get rid of the Fs. Because this guy is independent of Fs, all information up to the time S. And you have a property for the conditional expectation that if you have an X that is independent of a sigma field is equal to the expectation of it. So what would be the next term in this? So the expectation of Ws square given Fs. Right? What is the relationship between Ws square and Fs?
Measurable.
So it's measurable. So you're gonna take it out. Okay. Okay. Expectation of W of S square given Fs, right? So this is measurable, so you can pull it out, and the expectation of 1 is 1, so you know what to do. So what would be the next thing? Minus or plus 2 times of expectation of W of T minus W of S, okay, times W of S and given Fs.
It would be Wfs times expectation.
So what will happen with the first term? So this will become T plus S.
Minus S.
T minus S, sorry. Yes, it will become T minus S. This would be same as W of S square. You can pull this guy out.
WFS, Baki or T minus S.
Baki is independent of Fs.
T minus
So
S.
it would be
It can be expectation of Wt minus Ws,
which is 0.
which is 0, so this guy goes to 0. Okay? And you have also this lonely T sitting
Minus.
minus T, you can get rid of it and okay. What this process is
Martin.
making jumps, do it precisely, at least for once. A similar argument would run here, a similar argument would run here, for sure.
Right.
So you just have to think. Here you have to compute the expectation. For example, you want to prove, let's say, what are the key thing that is that you're going to find a bit? No, not really difficult. But try to figure it out for yourself that why this must be integral. Okay, the hint is keep in view that this is a normal random variable. And you have an exponential of normal. Then you have something that helps you to compute the expectation of exponential of the normal actually. So you can think of
Characteristic function.
Huh?
Characteristic function.
Characteristic function are, immediate function also.
And so this fs is fsw, right?
Obviously, everywhere is satisfied.
Got it.
Obviously, it's everywhere is satisfied. So these are 3 examples of martingales. Another interesting, proposition for you. Is this? It's really analog to what we proved in discrete time, so we may try to prove it here as well. We did it in discrete time, so prove it here.
It's like question number.
So if I have a martingale, the martingale,
It's independent. It's
say with respect to a filtration left key, which is not necessarily natural filtration.
WG minus WG square.
Okay.
Yeah.
Then you can see this, that if you have expectation of square of MT minus the square of S given, that's right. This is same as expectation of M of E minus M of S squared given Fs. You remember you did something similar in discrete time? If you have a martingale, expectation of the square of the difference, expectation of difference of or increment of a square of a martingale given Fs is equal to the square of the increment, actually, expectation of the square of that. Do it for yourself, something for you. Okay, there are lots of small exercises related with it. Yeah, by default, gift for you. Okay. All right. Would you like to do a break?
Yes.
10 15 minutes, not more than that. Let's do the break for 10 15 minutes and then let's do some more properties of Brownian motion. Just continue.